So how do we do this? And they want us to graph the image of triangle PQR reflected over the x-axis. So let's put down the x-axis, which is right there. To be clear on that, that's the x-axis. And so what we want to do is we want to take each of those points one at a time and reflect them over the x-axis. So remember how reflections work? I'll do it one point at a time. You take, like, for example, point P, and you go straight at the line. So you go 1, 2, 3. It took me 3 jumps to get to the line. Same distance, other side, right there. So it's 3 jumps straight at the line, and then you go the same distance to the other side. That'll be the image of point P. And then you do it with the other 2 points as well. So now I'll take point R and I'll go 1, 2, go straight out the line, same distance, other side. Is that good there so far? And then Q, 1, 2, 3, 1, 2, 3. Same distance, other side, just like that. And so the new triangle is going to be the connecting of those new 3 dots. So let me do that for us. So these 2 connect, these 2 connect, these 2 connect. There's the new triangle. So we just reflected that triangle over the x-axis, and it looks like it, huh? Doesn't it look like we just took the x-axis and we turned it like a barbecue rotisserie? We just turned it and it just kind of flipped the triangle over the x-axis. Oh, remember that when you do this, you have to double click when you finish the triangle. That's how you let the graphing system know that you've finished the triangle. So when you put the dots in, you click on the dots, you know, to make the new triangle. Double click as you finish the triangle. That tells the graphing system that you're done, and that way you can submit your answer. So again, how do we reflect? Think about a mirror. Like when you look into a mirror, your image looks like it's the same distance on the other side of the mirror, huh? When you get closer to a mirror, it looks like your image draws closer to the mirror. When you back up from the mirror, it looks like your image backs up from the mirror. So that's what a reflection does. For each point, it moves straight at the mirror, same distance to the other side. So 3, 3, and then 2, 2, and 3, 3. Now let me, you might have y-axis. So let me erase this and let me change the problem to y-axis, because you might have y-axis on this one. So let me change it, because it could be y or x. I'm going to show you y now. So now let me do a y-axis, same kind of thing. What if they said reflected over the y-axis, which yours very well might say? How would we do that? Well, it's the same basic idea. You move straight at the mirror. This time the mirror is the y-axis. 1, 2, 3, 4. So that's 4. 1, 2, 3, 4. Doesn't matter what order you do the points in. I'm just starting with that top one. Doesn't matter. And 1, 2, and 1, 2. Be right there. And this one's going to go the other way. 1, 2, 1, 2. Right there. So and then just connect the new 3 dots. So these 2 connect, and these 2 connect, and those 2 connect. And there we go. So now I just reflected the triangle over the y-axis. It looks like it, doesn't it? It looks like we took the y-axis here and turned it like a barbecue rotisserie, and the triangle just flipped over the y-axis. Again, don't forget to double click when you finish your triangle. So does that make sense? So for mirror images, mirror reflections, we take every point, we go straight at the mirror, same distance other side, 4, 4, and this original 2, 2, and then the Q started on the left, so he's got to move to the right, 2, 2. And so there we go.